Hey guys, how's it going? So we are going to start to review a little bit about our stats unit since we kind of got interrupted a little bit. So before the break, we were starting to talk about measures of central tendency, meaning mean, median, range, interquartile range, and also we started to do box and whisker plots. So I kind of wanted to go over what all of this stuff was once again and just kind of get our thinking caps back on in the stats mode. So we're going to talk about visualization of the data, starting with some frequency tables and ending with box and whisker plots. So do you guys remember before we went on break, I asked you guys all every single class period, I said, hey, what age were you when you found out that Santa Claus wasn't real? And we compiled your entire class's data. Well, I didn't take that, but I came up with a different data set. And it varied. Some people never believed in Santa Claus, so they said that the age they found out Santa was 0. Some people still believe to this day, or maybe I broke the news to them. I am so sorry about that. But we took all of this information, all of the ages at which people found out that Santa wasn't real, and we started to create data. And what we could have done is created a frequency table, because normally we just had like a big list, right? Like asked you guys up and down the rows, all right, hey, what age? You have a minute to decide. And then we compiled data that way. But it became a little messy when we started to find mean, median, and mode. So frequency table is a way to organize the data based on how often something occurs in a data set. And this comes in super clutch when we start talking about finding a standard deviation, because it can be a real pain and the data sets can be super large. So a frequency table just organizes it based on how often something occurs. So for this particular data set, three students never believed in Santa Claus. One student was the age 1 when they realized that. One student was age 16, and so on and so forth. So you can kind of see that the age is up at the top here at the top of our table, and then how many students were that age when they realized Santa wasn't real. So we can see that there was 3 at age 0, 1 at age 1, 3 at age 5, 5 at age 6, which is quite a lot. 3 at age 7, 3 at age 8, 5 at age 9, another one that occurs pretty frequently, 4 at age 10, 2 at age 11, 2 at 12, 1 at 14, and 1 at 16. So, I mean, there's our actual data set. So you can see how looking at all of this information can kind of be overwhelming. And luckily, this actually is ordered from least to greatest, which is what we needed in order to be able to find the median of our data set, right? In order to be able to find our median, we had to organize our data from least to greatest and figure out the middle of our data set. This frequency table kind of breaks it up a little bit nicer. So something else we did was we created a dot plot, and it is essentially a graphic display of the frequency table. So although I didn't specifically bring up frequency tables, and I apologize for that, when we were talking about this back in March, you can see that taking that large data set that we had here, 0, 0, 0, 1, 5, 5, 5, 6, 6, 6, 6, 6, 7, 7, 7, 8, 8, 8, and so on and so forth, we created a dot plot just like this before. So you can see that we're taking the 3 students at age 0 and doing 3 dots above that 0. First, we had a number line, right, in order to create our dot plot, and then we made a dot everywhere that data value occurred. So there was 1 value at age 1, so I'm going to put 1 dot there. The next age was 5, so I'm going to go over to 5 on my number line and do 1, 2, 3 dots because there was 3 students at age 5, and so on and so forth. And this was kind of like what our dot plots looked like. So dot plots are just a visual representation, a different way to show a frequency table. And looking at this dot plot or looking at this frequency table, we can easily see that the mode, the values that occur the most often is age 6. Age 6 right here has 5, and also age 9. Age 9 also has 5 values. So it kind of gives me an idea of the spread. I can, based on this data, make an inference that people were mostly between the ages 5 and 12, when they found out that Santa wasn't real, probably closer between 6 and 9, or maybe even 6 and 10, but that they were fairly young when they found that out, and it's really easy for me to see how frequently something is occurring. So, again, we covered this before we went on break, but just to give you a little bit of a refresher, here's all of the vocabulary terms that we are discussing at the beginning of stats, right? So, mean, or often referred to as X bar, X with a little like bar on top of it, is the average of the data set. We add all of the values in the data set and divide by however many there are in that data set. The median, I kind of remember telling you guys that I think of the median like the median that separates the highway in between exactly half on the freeway and separating northbound traffic from southbound traffic. The median divides the data set completely in half. So it is the absolute middle of the data set. Something to be mindful of for the median is that the median has exactly 50% of the data on the left and 50% of data on the right, or 50% of data on the lower half of the data set and 50% of the data on the upper half of the data set. The mode is the thing that occurs the most frequently. So a great way to remember mode is it sounds a lot like the word most. So we're just trying to see which number appears the most often, which value is occurring the most frequently inside my data set. An outlier is an abnormally large or an abnormally small value in the data set. So when we were talking about this back in March, we were discussing siblings, the household size or number of siblings that people had. And we had a situation where I asked another person and they said they had 11 siblings. Most of the people, I think we had an average of 3 or 4 siblings. So 11 was a really large value in that data set out of that little sample survey that I took. And so the outlier was the value 11. If something was super, super small in the data set as well, that would also be an outlier. The range is not to be confused with the range of a graph or the y values, but it is the difference between the largest value in the data set and the smallest value in the data set. So when I'm looking at a bunch of numbers, it gives me a really good sense of where they're going to lie if I can take the largest number in that data set and subtract it from the smallest number in the data set. And then when I'm talking about largest and smallest, I'm really just talking about the maximum, the biggest number in the data set, and the minimum, the smallest number in the data set. Then this is where it gets into a little bit more descriptive language. So we can split our data into quartiles. And last time I asked you guys what you thought quartile means, and some of you brought up a quart of milk, which means it's 1/4 of a gallon. Some of you brought up a quarter, which is 1/4 of a dollar or 25 cents, right? But we can split up our data into 4 different quartiles, 4 different pieces. The lower quartile can be found by taking the median of the lower half. So something to keep in mind is when I'm finding that median, I have found the middle between my data set. So I have split my data into 2. I've split it into 2 2 different sets. And if I take the median of the lower half, the values to the left of my median, I can find my lower quartile. And if I take the median of the right side of my data set to the right of my median, take the median of that values, I can find my upper quartile or Q3. Something to keep in mind is lower quartile is referred to as Q1, lower quartile is referred to as Q3. And lastly, the interquartile range is just kind of like we had the range between the highest value of the data set minus the lowest value. It's going to be the highest value, which is going to be Q3, subtracting Q1. So I want to know the difference between the upper quartile and the lower quartile, because in the future we're going to talk about a very special relationship that happens in that interquartile range. So taking all of this information, like I said, this is a pretty good refresher, is we're going to look at the following data set. So the table below shows the average monthly water temperatures for 2 locations on the Gulf of Mexico. How can we compare the 12 water temperatures from St. Petersburg with the 12 water temperatures from Key West? So looking at these 2 data sets, I've got a table here, right? And this is just telling me that it's the temperatures in degrees Fahrenheit. And the locations are St. Petersburg, Florida, and Key West, Florida. So obviously they're both in Florida, they're both on the Gulf of Mexico, and they're pretty popular vacation destinations too. And this table is just comparing the monthly temperatures. So in January, St. Petersburg was 62 degrees Fahrenheit and 69 degrees in Key West, Florida. Similarly, February, March, April, May, June, July, and what statistics is great for is like just looking at this data, we might be like, yeah, just looking at this, it appears, that every single month, if I do a little comparison, St. Petersburg is colder. St. Petersburg is colder. St. Petersburg is colder, 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 colder. Yep, you know what? I think St. Petersburg temperature is colder. And Key West temperatures in the water are going to be warmer. But that doesn't really give us like any definitive information. Like we can say that we can see that, but people always want us to quantify. They want to say, well, how much warmer? Because if you were to go swimming in that ocean, you would care if the temperature was 1 degree warmer. Wouldn't really make a difference versus like maybe 8 to 10 degrees warmer. That makes a huge difference, especially if you're planning a vacation of some sort. So in order to compare data, we really should be comparing the mean or X bar. That's what I mean by X bar, this little X with that little flat guy on top of them, little line. The median, the mode, range, and interquartile range for each data set to make a really good inference on what's actually happening with this data versus being like St. Petersburg is colder. I want to know how much colder. How do I know? Is it always going to be colder? By how much? So the first thing that we have to do is we were just given this table, and the only way that it's really organized is by month, which makes sense because, we like to organize things. But what we really need to do first is to rearrange each data set so that it's in numerical order, meaning it's going to go from the smallest value to the largest value, because eventually I'm going to have to find the median. Pardon me. So it makes sense that we just start off doing that because it doesn't affect how I calculate the mean. So for St. Petersburg, Florida, excuse me, I have a tickle in my throat. The coldest temperature that we have is 62 degrees. And then going through our data set, I see 64, another 64, 68, and continue so on and so forth, rearranging it in numerical order. I'm going to do the same thing for Key West as well. Whoosh, I think it's all of the talking that has my throat tickling a little bit. Being back, we haven't talked for a while, and now we're back talking nonstop. So we just rearranged each data set so that it's in numerical order. And what I want to do is I want to find the mean or X bar, the median, mode, minimum value, maximum value, range, and interquartile range for both St. Petersburg, which there's a beautiful image of St. Petersburg right there. And I also want to do the same for Key West. So I have this really cool resource that's going to walk us through comparing the data sets. I'm going to open this link to a video on YouTube. Okay, so like I said, I have a little video that explains how we're going to find all of these values really nicely displayed. So let's go ahead and get that started. All right, so in order to compare the two data sets between the water temperature between St. Petersburg, Florida and Key West, Florida, we're going to have to compare a couple of different things about the data sets. It wouldn't be enough to just simply compare the means of both of them. To get a really good idea of what's happening, we should really be comparing the mean, median, mode, range, and interquartile ranges to get a better overall depiction of what's happening with our data set. So let's go ahead and use this resource that walks us through finding all of these different values. And we're going to start with St. Petersburg, and then we're also going to go through the example of Key West, Florida.
First, look at the data for St. Petersburg. Arrange the data in order from least to greatest. The mean is the sum of the temperatures divided by the total number of temperatures. Add the temperatures from St. Petersburg. There are 12 water temperatures. So the mean water temperature for St. Petersburg is 75 degrees Fahrenheit.
Something I want to bring up really quickly right here is the fact that the reason that we know that there's 12 is because there's 12 months in a year. So if you added, this is January, February, March, April, all the way through December, obviously we know there's 12. And if we added up all of our data values for St. Petersburg, we would get 900. So 900 divided by 12 gives us 75, which is the average water temperature in St. Petersburg, Florida.
The mode is the most frequently occurring value. The modes are 64, 84, and 86, each occurring twice. Now find the minimum and maximum.
Before we move on to the minimum and maximum, I just want to bring up that it is okay to have no mode for a data set. Maybe nothing happens more frequently than another. It's okay to have just a single mode. It's okay to have more than one mode. Sometimes if we have two, we call it a bimodal data set. Sometimes this one's technically a trimodal, but oftentimes we actually just call it multimodal data set. And it just kind of gives us a better idea of what are the most frequent temperatures in this particular data set. When we discussed mean, median, and mode before the break, we had a few data sets that had no mode and a few data sets that had one or two, just one single mode or bimodal. Now the minimum and maximum are going to be exactly what you think they are. The minimum temperature of the data set and the maximum temperature, the highest temperature of water in St. Petersburg.
The minimum is 62. And the maximum is 86. The range is the difference of the maximum and minimum values.
It's always
so the
going
range
to be
is 86 minus 62.
It's always going to be the maximum value minus the minimum value.
Or 24. Now find the median.
So what's happening right now is we just grabbed the data set and rewrote it. And you'll observe that they started with just the whole data set and are starting to gray out from the outside in, kind of like canceling out 62 and canceling out 86, 64 and 86, 64 and 84. And they're going closer and closer to find the center of the data set. Since this data set is even, we should have two numbers in the center that we will have to take the mean value of.
For a data set with an even number of data values, the median is the mean of the two middle values. So the median is 76.
And how we got 76 is we took 74 plus 78, and that gave us 152. 152 divided by 2 is 76. Something else super important to note is the median will always divide your data set completely in half. Whatever is on the left-hand side of the median must, however many data values are on the left-hand side of the median, must also be on the right-hand side of the median. So notice if I have 2 values as my median, I have 1, 2, 3, 4, 5 data values on the left, and 1, 2, 3, 4, 5 data values on the right. My median will always split my data set 50-50. It will never be uneven. If it is uneven, it would not be the true median. So, for example, this data set has 12 values, right? Because there's 12 months in a year. And some of you might think initially, oh, well, the number between halfway between 12 is 6. But if I were to count the sixth value in this data set, 62 being 1, 64 being 2, 3, 4, 5, 6, the 64th data value is 74, and that leaves me 5 values on the left, but 1, 2, 3, 4, 5, 6 on the right. That is not truly the median, which is why I had to take the average of the two values of 74 and 78.
The first quartile is the median of the lower half of the data. The median of the lower part is 66. The third quartile is the median of the upper half of the data. The median of the upper part is 84.
So we found those medians in the same exact way, right? There was 1, 2, 3, 4, 5, 6 values because 76 is technically in between. So I needed to find the median of that lower part. So I needed these two values here. So I left 62, 64, 70, and 74 on the lower half of my data set, right? 76 is right in between 74 and 78. That's my median. So I'm taking the median of this half of my data set. So I did 64 plus 68 divided by 2 gave me 66. Similarly, we did the same on the right-hand side. Anything to the left of the median is considered the lower half of the data set, and anything to the right is considered the upper part of our data set.
To find the interquartile range, subtract the first quartile from the third quartile. So the interquartile range is 18.
Something to note also is the interquartile range will always be Q3 minus Q1. And because we organized our data set from smallest to largest, Q3 will always be the larger value. So we should never get a negative number for an interquartile range. So now that we've completely done that from St. Petersburg, let's do the exact same process for Key West so that we can actually compare our data sets.
Now look at the data for Key West. Arrange the data in order from least to greatest. First, find the mean. So the mean water temperature for Key West is about 79 1/10 degrees Fahrenheit.
I would just say 79.1 degrees.
Next, find the mode.
82 is popping up twice, as is 87.
The modes are 82 and 87, each occurring twice. Then find the minimum and maximum. The minimum is 69, and the maximum is 87. Now find the range. The range is 87 minus 69, or 18. Find the median.
Again, it will be the average of the two middle values.
The median is 80. Then
And take
find
the
the
median.
first quartile.
Find the first quartile by taking the median of the lower half of the data set. And similarly, find the Q3 by taking the median of the upper half of the data set.
The median of the lower part is 73 5/10. Now find the third quartile. The median of the upper part is 85 5/10. Finally, find the interquartile range.
So 85.5 minus 73.5 is going to give us an IQR of
The
12.
interquartile range is 12.
Alrighty, so here's the data that we've compiled for Key West and also St. Petersburg. St. Petersburg being the first data set that we compiled, and Key West being the second data set that we compiled.
The range and the interquartile range show the temperatures varying less at Key West than at St. Petersburg. Also, the temperatures at Key West are generally higher.
So something really interesting to think about is if we were to only look at the mean of the values, sure, we would get the same inference that St. Petersburg, since the average temperature is 75 degrees, and since Key West average tends to be 79.1 degrees, we could infer that Key West has typically warmer water temperatures. However, it doesn't give us a very good idea or very solid understanding of the data. So us comparing the modes also shows us that the most frequently occurring temperatures are higher in Key West than they are in St. Petersburg. Notice St. Petersburg has a mode of 64, which is significantly lower than any data values that we had in Key West. Also, if we compared the minimum and maximum values, the minimum was higher in Key West than it was in St. Petersburg, and similarly, the maximum was a little bit higher as well. Something that actually tells us a lot of information that doesn't seem to at first is the range. The range is 24, so that means there's a difference of 24 between the maximum value and the minimum value. So 24 degrees is how much the water temperature ranges. Since the range is smaller, since 18 is smaller than the number 24, that also tells us that the temperature stays fairly close to the average values. So the difference between 87 and 69 has a smaller range, which means it's going to tend to be a little bit warmer than the temperatures at St. Petersburg. Our interquartile range also gives us a very similar result. But overall, if we had just looked at one or two of the elements, we wouldn't get as well-rounded of information about the temperatures from Key West. So that's why it's really good to not just look at one particular measure of central tendency, but to take a collective look at all of the various measures of central tendency to really get a good idea in order for us to make valid inferences based on the information that we have presented. All right, so now that we have done that, let's go back to our data information, and we were here. Resume slideshow. So St. Petersburg, to reiterate, we found that the mean was 75, median was 76. It was trimodal, 64, 84, and 86 degrees were the important, the most frequently occurring temperatures. Minimum value of 62, maximum of 86, and we ended up finding that the range was 24 and an IQR of 18. Now, we did the same thing with Key West, and comparing all of these different data values gave us a better overall understanding of the value. So the reason why this is important is because we get to use this information to create a box and whisker plot. A box and whisker plot uses minimum and maximum values, the median, and the first and third quartiles to display the spread or variability in the set. So it's kind of like almost like the dot plots gave us a very nice visual representation of the data. A box and whisker plot does the same. So right here on the screen, oftentimes we have box and whisker plots that are horizontal, but they can also occur vertically. So you can see what I mean, where first we have to line up our values from smallest to largest. We first find our median of the data set. Then we take the median of the lower half and get Q1, our lower quartile. Do the same thing on the right-hand side of our value, find the median of the upper half, that gives us Q3, and then we draw these three vertical lines. We draw one at Q1, Q2, and Q3 and create a box. This is our box of the box and whisker. Then the last part of it is to just simply find the minimum value, put a little dot or a tick mark, and connect it to our box, and then do the very same thing with our maximum value. Now, the reason that we've calculated our interquartile range is because that is where a majority of our data values are going to fall. So normally we calculated our interquartile range being Q3 minus Q1, but I can just look at this box and get a very good idea of what my interquartile range is as well. So let's make our very own box and whisker plot. And we're going to use the data from St. Petersburg since we've just been rolling on a St. Petersburg kind of vibe. So this is the exact same data that we had from St. Petersburg. These are all of the temperatures of the water in St. Petersburg. So we found out already, we did a bunch of the hard moving already. We lined it up from smallest to largest, 62, 64, 64, 68, 70, 74, 78, 80, 84, 84, 86, and 86. That is our data set from smallest to largest. We found our median already, it's 76, and we found Q1 being 66 and Q3 being 84. So let's make a dang box and whisker plot. It's gonna be great. So I'm actually gonna get out of here and draw it live with you guys. Now, I don't have a cool stylus or anything, so bear with me. But here's our data that we're working with, right? We've got our median, we've got Q1, we've got Q3, and we can visually see our minimum values and our maximum. So in order to create a box and whisker plot, the very first thing that we have to do is create a number line. Now, you don't have to create every value, but it is important that you maintain a similar spacing. So notice that my number line, I've decided that my minimum value is 62 and the max is 86. So I'm going to do increments of 5. As long as you stay consistent, it really doesn't affect the box and whisker plot too much. It just consistency is key. So I did 55, 60, 65, 70, all the way up to 90. So the first thing I want to do to create my box and whisker plot is create a number line that has all of the values present. And then what I'm going to want to do is mark my median. That's the very first thing I found in my data set. We found that the median was 76. So 76 is going to be a tick mark right over here. And to kind of make it stand out, I'm going to change it to a bold black line right there. So that's my median. That's my Q2. I marked that guy first. Then I'm going to repeat the process and make a vertical line where Q1 is. And we found that median value to be 66, which is also going to be somewhere right down here, 66. Let me also make that a bold black line. And you guessed it, we're going to also mark a vertical line at Q3, the median of the upper part of our data set. So that number is 84. So 84 is going to be slightly below 85. I'm going to make that guy nice and bold. Okay, so we're almost done with creating the box part. Lastly, all we need to do is to connect these values with horizontal lines. And there's my box, all right? There's my box out of my box and whisker plot. I can see that right here is Q2, right here is Q1, and right here is Q3. You can see a majority of my data falls between the values of 66 and 76. So a larger value. It's a little bit skewed, but not by too much. And the last part I need to do of my box and whisker plot is to make my whiskers. My whiskers are going to be the minimum value and the maximum value. So my minimum is at 62. So I guess like right here would be 61. So 62 would be like somewhere right there. And then I'm going to go over to my maximum value. My maximum is 86. And it's like, maybe I want to make it the same. Maybe right there. So I've got my whiskers. And then I just connect them to my box. Voila. Oh, let me kind of extend this guy over here. And then connect to my box. Voila. So here's a really rough, rough drawing of a box and whisker plot, right? So your guys' assignment, since we've been talking about St. Petersburg and Key West, is what you guys are going to do is take the data from Key West, and you guys are going to draw your box and whisker plot for me, and then you're also going to explain the process. So you can see that in our HyperDoc, but that's a pretty good rundown of everything that we talked about up to box and whisker plots on stats. So I hope you enjoyed our little review sesh here. And if you guys have any questions, never hesitate to contact me. I'm always here for you guys. Alrighty. Thank you so much. Have a great rest of your day. Bye.